Hi everyone, welcome to our Sentic Labcast. I'm going to introduce our work published on AAAI 2022. It's called HiTKG. This model is able to reason over the dialogue and knowledge graph like human beings. So let me first introduce what is goal-oriented conversations. So as can be shown in the figure on the right, the girl says that I love the grilled fish so much. Then the dialogue system can identify the entity in this sentence. Then it reasons over the knowledge graph and gives the response containing the green entity. The green entity is the entity that the dialogue system pick from the knowledge graph. So now in this response, this green entity is named Chinese dish. It's one of the entities in the knowledge graph. Then given the answer that really I would say I love China, then the chatbot will reason over the knowledge graph again and give the response containing the intended conversation topic. So in this topic, there has been several works done by the researchers of this domain, but I haven't seen much work that can reason like human beings. Some work augments dialogue inputs with shallow entity and relation information. Another set of work focuses on developing a series of goals or topics for each conversation term by working on the KG. These graph workers are recurrent or graph attention-based models that attentively read the dialogues and reason over the KG paths, starting from the entity mentioned in the last user message. So this thread of work is very similar to our work, but we, besides from proposing a model that can reason over the knowledge graph on this, we also propose a global goal-guided knowledge graph reasoner. So to the best of the knowledge, we are the first that study global goal-oriented KG path transitions in dialogue. So let me introduce our contributions in this paper. We propose a hierarchical transformer. HiTKG is the first transformer-based KG worker that attentively reads multiscale inputs for graph decoding. We further propose multi-source decoding inputs and output level length head to strengthen controllability of the hierarchical attention-based graph decoder. So this graph decoder can reason over the knowledge graph based on the dialogue history and the knowledge graph history. So we will show you what is dialogue history and what is knowledge graph history in the later figure. So the second contribution is that we propose a two hierarchical learning framework to train the proposed hierarchical KG worker in order to learn both turn level and global level conversation goals. This is the first attempt to learn models to make natural transitions towards the global goal in KG, where we propose a distance embedding to incorporate distance information. Regarding this contribution, I want to reiterate that we are the first that do this global goal-guided dialogue system. But there are several related works, but they didn't explicitly let the dialogue agent to follow the global goal and achieve the global goal. So the third contribution is that we propose MetaPath to concurrently exploit entity and relation information when reasoning, which has proved essential as the backbone method for KG path representation. We will also explain that in the figure in this figure. So this is the overall working flow of the proposed framework. So I just mentioned we have two kinds of inputs, the dialogue history and the knowledge graph history. So the dialogue history is namely the conversation history between the human and the agent. It's like these utterances shown in this box. The KG, the knowledge graph history, can be seen as the knowledge graph trajectory, as shown in this box. In this box, the red entity and the green ones and the purple one and the connections between them forms a knowledge graph trajectory. So given the two inputs, we use two transformer encoders to encode these trajectories and histories, and we use a hierarchical attention to leverage these trajectories and make predictions on the knowledge graph path. So given this path history, we are going to reason what entity it should be in the next step. It has two options. One option is follow this path. One option is follow this path. And the model actually we have 5 options, but the model think that these 2 options are with low probability, and this option on the top of this node, the purple node is within the path history, so it cannot repeat the trajectory it has gone over. So it has 2 options, this node and this node, 2 green nodes, as indicated in the KG box. So it has 2 kinds of reasoning results. One is without the global goal guidance, and one is guided by the global goal. In this case, it's called iVegan. So let me explain what is a metapath. A metapath is a simple can be a simple concatenate of the relation embedding and entity embedding. So as we can see that in the transformer, we can stack the metapaths. We can stack metapaths, and the transformer decoder can reason over these metapaths. So basically, a metapath is a relation plus an entity, and it represents a one-turn goal trajectory. So based on this, once the transformer predicts on a metapath, it means that the transformer chooses a node, chooses a one-turn path. A one-turn path means that this path contains only one connection. So this is our results, our main results, that our proposed model can achieve significantly better results compared with the baselines. So the middle ones are some ablation studies, some variants of our models. So we can see that some of the results are quite good, and even some variants can outperform the baselines to a large extent. So we in this work we propose HiTKG, a hierarchical transformer-based KG walker that leverages multiscale inputs for graph reasoning in dialogues with a 2 hierarchy learning framework. HiTKG first learns to plan natural turn level goals and then learns to approach a global goal. And this is the core of our work. Both automatic and human evaluation illustrates the effectiveness of our methods. Please note that we study conversation goal sequence reasoning instead of utterance level response generation. That means that we don't explicitly generate utterances as the response of the agent. However, we propose a possible solution here. However, we can use similar learning methods of the proposed user simulator to train an utterance generator that generates responses based on the KG path. So if you're interested in this passage, you can get it by searching its name, HiTKG, and we have the PDF version on our website. And this generating utterance level response is our future work. In the future, we will invest how to improve the embedding learning framework and evaluation criteria of stage 2 to further extend this topic. Thank you very much.